So good morning, good afternoon, everybody, and welcome to another of our webinars for Enterprise 5G, private networking, private LTE, whatever you want to call it. My name is Ian Gillett from IGR, and I'll be acting as moderator today. Three great panelists today I'll introduce in a second, and today we're talking about transportation and logistics. This is, gosh, we've got one more in this series, actually in a month or so, but we've covered healthcare, education, manufacturing, etc. in this series of the webinars. We'll dive into the content in a few seconds. Just to let you know, we are recording today's webinar. And the recording will be on our website in a day or two. As soon as we get it uploaded, it tends to be a big file. If anybody wants to see the archive, we'll also take questions today. If you use the questions tab on the GoToWebinar control panel there, it's about halfway down, and we'll take questions. We'll either work them in as we go through today or just have time at the end for them. Just one word of warning, I'm down here in Texas. We had some pretty big thunderstorms come through last night and this morning. We actually lost power this morning. If that happens again, Matt Vartabedian, who works with me at IGR, he's also on the session, and we'll pick up the session if you lose me. So hopefully it won't happen, but just in case. All right, so first thing I need to do is thank the OnGo Alliance. They're the folks who worry about CBRS and standards and all those good things. And if you see Mr. Jim Jacobellis there, if he holds up his right arm, yeah, you'll see the logo. There you go. And if Oza lifts up his, stands up a little bit, he's got the CBRS shirt on. Mark is the only guy who came properly dressed for today, as you can see. So, but I want to thank the OnGo Alliance. They actually support us with everything we've been doing with this. The other thing I'll mention is we're going to announce fairly soon here, we've been putting together plans for Enterprise 5G Live. It'll be a live, real-life conference in October 20th and 21st at the Santa Clara Convention Center. So we've got the brochure together, getting the website together right now. I'll be announcing that shortly. So, all right, so with that, speakers today, I updated my photo finally. Jim even commented on the other day. But we've got Jim Jacobellis from Geoverse, Mark Brandt from Nokia, and Oza, and I never even try with his last name, and he forgives me for that, but Oza, who's VP of Marketing for Solona. Again, we will be taking questions, so just let us know any questions as we go through. So I'm going to kick things off, kind of overview private networks a little bit, talk about the transportation logistics, how big the opportunity is, and then each of the speakers is going to go through their decks for 10, 12 minutes each. Basically, we're going to spend a lot of time on the use cases today. We're going to cover different aspects of this, but as we go through this, you're going to see use cases for long haul, trucking, delivery, etc., vehicle communications, airports, ports, transportation hubs, warehousing, etc. So it's a pretty broad in vertical, this one is. Actually, when you look at the vertical itself, it's actually not defined by the government as one vertical, and I'll talk about that as we go through as well. We'll talk about the communication needs, we'll talk about CBRS, we'll talk about 5G, we'll talk about some of the different applications that support those use cases as well. Wrap it up, then we'll do the Q&A. So in terms of, this is the slide I've used before to kind of show the world with 5G, if you like, in a few years' time. What we're really talking about today is the red areas here, the ones that are outlined in red. So obviously transportation is up there at the top. That was kind of my attempt at a warehouse. I probably failed on that one. But certainly you've got drones running around, you've got automated vehicles, you've got, there's a lot of automation in warehousing today. Obviously aircraft, we could have communications on the aircraft. There's actually an announcement today by AT&T with Delta Airlines actually extending 5G for the cabin staff, for example. There's also communications needed and applications at the airport itself, and not just for passengers, but also for airport operations, airline operations. And I think Mark's got a couple of slides on that that are pretty good. We could also get into public transport. As I said, there's long haul trucking as well, that communication need over a wide area. Jim will talk about this. And then we've got manufacturing as well. Within manufacturing, there's a logistics component to there, automated vehicles within the plant, robotics, etc. And Oza's got some slides on this. So we're going to cover different aspects as we go through, but this is kind of the big picture here. So how big is this? Now, as I mentioned, the government doesn't have one category for transportation and logistics and warehousing. So rather, unlike education or manufacturing or healthcare, where there's one CBEX definition, there's actually multiple definitions that encompass transportation and logistics into them. So there's a transportation model, which is this one, and this actually I pulled from that airports and rail and bus terminals. This is actually included within the bigger public assembly category that also includes things like gyms, conference centers, public town halls, etc., etc. But if you just look at this data, you see airports there on the left, about 19,000 buildings in the US airport infrastructure. Now, if you take something like DFW, that's going to be quite a few buildings, right? If you take something like Dallas Love Field, it's really one big building. So it depends how the airport is structured and how it gets counted. The different categories here are the size, and that's in square feet. So you can see the majority, well, actually 47% are actually 10,000 to 25,000 square feet. So if you have an airport with 4 terminals, let's say, each of 25,000 square feet, it's going to count 4 times in the green area. You can see as we go up there, there's actually relatively few in the larger categories there. And there's very, very few in the 1,000 to 5,000 square feet. My parents live in Ithaca, New York. I think that would probably qualify that. It's a pretty small airport. Rail and bus terminals are on the right-hand side. There's actually about 12,700 there. You'd think there'd be more, but actually there's not. I guess that shows you how much infrastructure we have in the US for flying. If this were Europe, you'd see a completely different view, obviously. But again, now look at this mix. You can see the mix skews much more towards the smaller building. And if you think about the typical railway station, it could easily be 5,000 square feet. It could be 1 or 2 platforms, depending on what it is. But obviously, pretty big opportunity there. Now, the other one is warehouse and storage. You know, how big is it? How fast is it growing as well? This is in a separate category within CBEX. Again, on the left-hand side, you can see the number of buildings, and it's in thousands. And you'll notice the scale. I put the scale, so it starts at 1 million buildings. This space actually has already grown 10% from 18 to 20. It actually grows 50% between 18 and 2026, if you look at it. Great space. Now, why? And I could have one word answer here, would be Amazon, but I think it's also Amazon, Walmart, etc., etc. And this is one area with COVID that really has not suffered at all. There's obviously been increased demand as we all started ordering even more stuff from home. The other one is, if you look on the right-hand side, you can see the square footage there. So this is in millions of square feet. So it's 27,000 million square feet. But you can see it goes from 17,000 up to 27. That's a lot of space. So the number of buildings is increasing by 50%. The square footage covered is actually going up by more than that. If I could do the math, what's that? It's going up by 60%. Over the same period. So not only are we getting more warehouses, we're getting bigger warehouses. And of course, wireless is a big component of this. We'll talk about this as we go through the case studies. So with that, I'm going to hand over to Jim from Geoverse. Jim, 10, 12 minutes, away you go.
Okay, well, thank you, Ian. A great overview. As background, I'm sure Geoverse is not a household name for most, but we're a wholly owned subsidiary of a publicly traded company that goes by the name of ATN International. Worldwide operations, but in the US, we're divided into 3 business segments. First being service provider solutions, where we play the role of being the wholesale roaming operator to the US carriers, T-Mobile, Verizon, AT&T, in approximately 15 states. So if you go to those states where we fill in the holes for them, you'd be on our network and not their network. Places like the Grand Canyon, places like ski resorts in Colorado, etc., in that kind of general footprint. And then we also have a rural and broadband side where we've been delivering fixed wireless, fiber services, typically, again, in rural areas. And then the new part that I'm part of is the private network part. So leveraging all those resources and assets that allowed us to be a carrier and throwing them toward this new private LTE, private 5G, private network space, kind of the where the enterprise or the city is able to become their own network operator, if you will. So one of the tasks that I received from Ian was to start with the building blocks of creating a private network. And so what is CBRS? We're throwing it out there like everybody knows it. And how can I leverage that piece of spectrum to build my own private network? And so if you go to the next slide, I think, I'm assuming everyone knows what wireless spectrum is, but up until a couple of years ago, I'd say most cellular private LTE or LTE transmissions happened in spectrum to the left in that 600 megahertz to 2.5 range. And the characteristics of that spectrum were signals went a long way, but you did not have a great pipe. So think of it being really good for voice and for bursty data and things like that. And then in 2019 and then again in 2020, the millimeter wave spectrum was awarded and to the various operators that bid on it. And so that spectrum has got a lot of attention lately because it's being touted, or was touted as the 5G spectrum. And it is being used for 5G initially by some of the operators, but it has its limitations. It is got a lot of spectrum. You can get a really big pipe. But the problem with that spectrum is the signal didn't travel very far. It was only line of sight. It didn't penetrate into buildings. So it's primarily being used in really dense urban areas. And it wasn't generally available for enterprises to use for their own purpose because it was auctioned off to the operators. In January 2020, if you look at the middle now, the CBRS band became available for shared use by anybody in the US. And then this year, the C band was auctioned and awarded. So that middle part is referred to as the mid-band spectrum. And most folks in the industry believe that mid-band is going to be the sweet spot, the future spot for things like 5G, where you get those non-line of sight characteristics, goes a long way, yet you have enough spectrum to do all these wonderful things related to digital automation, Industry 4.0, and what have you. And yet it can be used privately by an organization. And just to kind of show you a picture of what this means, the CBRS band is the band that, if you look at it compared to what the Verizons, the T-Mobiles, and AT&Ts had in the way of spectrum, it was equal to or greater than, prior to the Sprint T-Mobile merger, than the spectrum that T-Mobile and Verizon had, and just about the same that AT&T had, that they spent billions of dollars for, that is now available for use for free for enterprises to use for LTE, 5G in the future. That before was only available in the sandbox of public cellular carriers. And so now enterprises, again, cities, schools can now use this spectrum for what it was kind of meant to do, for innovative new use cases. And this slide is kind of a Geoverse related slide, but I think it points out the foundational elements of how to build a private network using CBRS band, or if you're lucky enough to cut a deal with somebody who is able to bring you a different sort of spectrum. Again, it's the spectrum combined with the radio. And if you're familiar with Wi-Fi, Wi-Fi has a radio. It's called an access point. CBRS has a radio. They call it an access point sometimes. They call it a lot of other things, including RAN, including a CBSD. But again, it's the radio portion. And you combine that with a core. Typically for transportation and logistics, that core sits at the edge because the user wants full control. They want to see and control the analytics. They want it integrated into their service layer, et cetera. And that is combined with devices, whether those devices be IoT, whether they be smartphones, whether they be tablets, et cetera. And those devices are fitted with SIM cards that then communicate back to that radio layer. So, SIM cards, the authentication with SIM cards provide an element of zero trust in a private LTE network. There's also some other elements that go into that, but that's the new thing versus Wi-Fi. And then in certain cases, I think Ian was mentioning asset tracking and long-haul trucking and things like that. There's a need to go off your private network onto a public network and vice versa. So connectivity, interconnection to the public cellular network is the other kind of building block as we see it for a private network. Now, of the kind of, I hate to use this word, but of the verticals that have business problems related to connectivity, I would say industrial, warehousing, transportation, and logistics are, if they're not at the top of the list, they're at or near the top of the list. And the reason why is that public cellular Wi-Fi hasn't been good enough for many of the applications that are going on associated with Industry 4.0 and other initiatives. And then wiring and fiber have not been practical for this environment. So private LTE, I don't know what term are we using, in private LTE or private 5G today, it offers the right combination of security, reliability, coverage, big coverage advantages over Wi-Fi to meet those business needs associated with whatever we're calling this planned digital transformation. Now, as far as early use case goes for transportation and logistics, this is what we were seeing. There's probably more, and I'm going to combine a couple when I speak of them. But if you look at voice, if you look at data, if you look at push-to-talk walkie-talkies, point of sale at airports, where the airport is actually kind of now has a network where their tenants can use this for point of sale transactions. This is kind of a device consolidation or network consolidation story. You now have a single network where you can put all these things on at once, again, with all the security, reliability, and coverage that was hard to do before. Also, some of the autonomous, the robotic, the video, the VR things happening. I mean, I have a couple of airport examples, but this is also happening inside warehousing, inside manufacturing. Wi-Fi was not good enough for these applications. You know, in a nutshell, it didn't have the latency and the predictability for a wireless signal for that sort of application. And then even some of the ones that are popping up is, does it make sense for me to fiber up where these EV charging stations are, or do I use this kind of air fiber alternative, to do that? And then also, Ian mentioned this, when you have this private network, but sometimes you have to go off that network and vice versa. And so that asset tracking to go on and off that network is also, an important use case. And then I think for the last two slides, I think just it's more of a side note than anything else, but CBRS auctioned off, or FCC often auctioned off part of the CBRS spectrum for preferred access use. And this is just a map of where Geoverse purchased preferred access licenses. And as you can see, a lot of these are in and around port areas. And then if you switch to the next slide, we're also, because we're now in the private network business, we also have 600, 700 megahertz in traditional cellular spectrum that is going into private network. That is typically used for mining and oil and gas type applications. So that was the last of it. Ian, I turn it back over to your next victim.
Great, thanks. So just to be clear, Jim, looking at these two maps here, if I'm let's say I'm a long haul trucking going between, Arizona and Nevada or something, I could actually build a private network with you, and it would be private all the way, both on the wide area networks as well as in the depot, right?
Yeah, if not, you could take advantage of our roaming agreements with an AT&T or somebody like that to fill in the blanks.
Yep. Okay. All right, Mark. There we go. So Mark from Nokia, he's got some great slides on, he's got some great use cases actually on airports and ports. So Mark, over to you.
All right, well, thank you, Ian, for the introduction and for the opportunity to participate on this panel where we're discussing how private wireless networks can form the foundation for a transformation to industrial 4.0. So for those that may not know, Nokia is a major global manufacturer of network infrastructure, software, and services, primarily for the world's carriers, but also for the enterprise environment. And one of the products in our enterprise environments are the ultra reliable, industrial grade, private LTE 5G networks. Next slide, please. And so here we can see some of the logos of folks that have came alongside Nokia to partner with us as they embark on this digital transformation journey, and where they found the ultra reliable networks to be the table stakes for then being able to deploy other technology on top of that, needing that connectivity to get things going. Next slide, please. So one such opportunity in transportation is for airport operations. Airport operations are heavily still using pencil and paper for their processes. And it's not because of a reluctance to embrace new technology, it's because the connectivity options that they had available to them previously did not allow for it. So their options were using the public cellular network or Wi-Fi, and with public cellular, they're competing with the passengers for access to that network, and that can be problematic. And Wi-Fi, because of the vast distances and coverage areas required, is not a very reliable medium. So enter the picture private wireless networks, and these can provide all the coverage that's needed along with reliability to be able to meet these needs. And so some of these needs, include traditional Internet of Things applications, such as monitoring the whereabouts of ground service equipment, the tugs that are pulling the baggage carts, loaders, the fuel trucks, different things like that. Having an awareness back in the command center of where all the assets are. And that's important because in an airport operations world, what's paramount is get the planes out of the air, on the ground, to the gate, unloaded, reloaded, and back up in the air again as quickly as possible. But with anything, with a large industrial environment with very complex moving pieces, anomalies occur daily. And when they do, you need to have good situational awareness so that all the stakeholders can make collaborative decision-making processes to ensure that they minimize this aircraft turnaround time. So with that, one of the very popular methods of enhanced situational awareness is deploying video cameras. So with the private network, you can easily get your network connection, whereas previously it may have been cost prohibitive because this is very expensive real estate. You have to trench that tarmac up and run a fiber out to a light pole to hang a security camera on the video camera. That can be very costly. But now if you can just hang the camera on the pole, tap the pole's power supply for the light, and get a network connection via the private network, then you can start deploying these wherever you need them. And particularly if you deploy pan, tilt, zoom capabilities and let the airport command center drive those cameras. In addition, putting those same type of cameras on top of vehicles has proven to be very popular as well. Again, with pan, tilt, zoom, so that when a first responder responds to an incident, not only is the command center getting his assessment of what he sees in front of him, but they can also zoom in from vehicle mounted cameras and other cameras at their disposal to see for themselves what's going on. And as a result, being able to get a quicker response. So the private wireless network in the airport environment will cover, the one network will cover all the needs that are out there for push to talk, push to video, general broadband access, collaborative communications, IoT and video. It does it all. And so there's one network that's ultra reliable that can provide all those needs. So with that, if the airport can increase the throughput of plane movement through its facilities and increase efficiencies, they will both increase their revenue and lower their costs simultaneously, and that creates economic headroom for investment in technology. So let's take a look at another logistics use case, and that would be in the warehouse environment. Here, the traditional wireless access has been Wi-Fi, and it worked very well when you were doing simple operations such as barcode scanning of packages or pallets from a handheld device from a relatively stationary position, or you had a tablet where you were walking around accessing the warehouse management system and maybe performing some supervisory functions. So it worked very well for that. But then as they tried to start implementing more technology to increase efficiencies, in came the autonomous vehicles. And the most popular application in an order fulfillment distribution center environment is the cobots that are used to assist in picking and order filling operations. So there, a worker is in an area of the warehouse and the autonomous cart comes to him. He picks an order, puts it on the cart, and it goes back to shipping and processes it for shipping. He stays at his station and the next cart comes in and he's filling orders. So they get great increase in efficiency with that, but with it comes a mobility factor where Wi-Fi starts to struggle a little bit. You get you find that a few of these works really well, and then you add a few more because you need more efficiencies, and soon you get a point where you're causing problems on the Wi-Fi network. Then there are the forklifts. And so the forklifts have now become a technology aggregation point in the warehouse environment whereas a tablet mounted on the forklift is the starting point, and maybe dispatch instructions or other information is displayed to the driver. But now with smart fork attachments that have all kinds of technology embedded in them, scales to weigh a pallet when they lift it, HD camera to do imaging. There's all kinds of neat things they can do with imaging, and soon we'll be seeing palletized, being able to dimension pallets from this type of technology. In addition to RFID readers and barcode scanners, there's a whole host of technology being deployed in the smart forklift. And these forklifts move at a pretty good clip throughout the warehouse. So it can create mobility problems with Wi-Fi in that environment. With Wi-Fi, depending on your security configuration, and you have a lot of access points in there to provide the density and the coverage, when that forklift is moving through the facility, it's running past these access points at a pretty good clip. And it's trying to upload its data while it's doing that. However, depending on the security scheme, it's got to reassociate, re-authenticate. And so when that process is underway, there's no data being transmitted. So you ended up running past access points before you really get a chance to transmit your data. And so it can become problematic very quickly. But with the private wireless networks, that's not an issue. Coverage takes far fewer access points, if you will, for the private LTE 5G setup than it does for Wi-Fi. And actually, in addition, it's more cost effective to deploy private LTE in a warehouse environment over Wi-Fi, even across the life cycle of the deployment. So we see a number of interesting use cases here, anywhere from the autonomous vehicles and smart forklifts to, voice communications, push to talk, push to video, being able to deploy virtual reality, augmented reality for training and picking. These are all good applications. Again, picking up security cameras, the flexibility to deploy those where they're needed, including on the exterior where it was cost prohibitive to put them before, and you can get quick ROI from reduced theft and loss at the facility by having security cameras around the perimeter. So all in all, again, the same model here. Increased efficiencies means more throughput through the warehouse, which increases revenue, along with lower cost of operations, fewer people needed to run the warehouse. So it's a win-win for that environment as well. So next, we'll take a look at the port environment, maritime ports. So here you see a shipping container port. And the things to notice here are the cranes and what we call the straddle carriers that move the shipping containers. So when a ship comes in, it's loaded and unloaded with the cranes. Well, in an automated port facility, they may choose to remote control the cranes and have the operator sitting in an office controlling those cranes by connectivity via private LTE or 5G. And with a series of cameras mounted on the cranes, they get the visibility they need, and they can operate and load and unload the ship without being in the crane boom itself. So there's some manpower efficiency savings there, but just think about that for a minute. The private LTE is reliable enough to allow that. To me, that was an eye-opening experience when I first found out about that. In addition, the straddle carriers that normally require a manned operation for somebody to manually operate that straddle carrier, they're automating that process where they're becoming autonomous, and they're just following the instructions of the terminal operating system in the port and its applications, saying go pick up these containers, take it to this point, load it on truck, rail, or whichever. And so they increase their throughput and vastly reduce their manpower costs, again, building the economic headroom for investment. And so for our final slide here, we'll take a look at a use case where the Port of Seattle selected Nokia to provide a private LTE system operating in CBRS and Band 53 to be able to provide access to the terminal operating system from handhelds and tablet devices. And in doing so, they had problems transitioning from indoors to outdoors, and reliability issues. And with the private network, they were able to seamlessly roam inside and outside from one band to the next. And they got a much more reliable communication system that will form the foundation for future technology deployments. So they too are enjoying the benefits of industrial grade, ultra reliable networks. And so with that, Ian, thank you for the opportunity, and be available for questions later.
Great, thanks, Mark. And as somebody who's put together a lot of slides over the years and images, those pictures that you guys put together, somebody spent a lot of time building that airport, I tell you. I built my own, it took a while. As Mark mentioned, we will be having questions. We've had a few come in. I'm going to leave them until Oza has spoken. So Oza from Salona, let me get the slides up. And Oza's got some more use cases, but he's also going to talk about devices, which is something we haven't really mentioned yet today, which is obviously a big part of this. So Oza, over to you.
Awesome, thanks Ian. Hello everybody, very nice meeting you. Just a quick introduction to who we are. As an engineering team, as an innovation team, go-to-market team, we really come from an enterprise first background. I spent 10+ years at Aruba, from its initial days of cutting cables to its growth phase and acquisition through HPE. And several of my colleagues share a similar background in the fact that we wanted to build a private LTE 5G solution that is purpose designed for the enterprise environment. So hopefully, as I go through the slides, that will be more obvious and apparent to you all as well. So in the next slide, diving a little bit deeper into, how does enterprise view CBRS? Obviously, there's already a pretty good friend of ours in place in the enterprise environment. It's called Wi-Fi. I worked on Wi-Fi for 15 years, and I know what it's capable of, and I know what it's not capable of. One thing it's not capable of is having a heavily coordinated, interference-free operation in terms of its spectrum allocation and spectrum use. So that is a big benefit for critical environments, critical infrastructure, where you do not want to deal with Wi-Fi interference. You do not want to deal with clients behaving the way they want to behave. You want their behavior controlled by the infrastructure like LTE 5G does. You want to not only offer quality of service to those devices, but you also want to guarantee throughput, latency, packet error rate, SLAs, availability SLAs to that wireless link. Those are the things that we can do now on enterprise wireless using CBRS spectrum and using cellular wireless LTE 5G. So that's pretty big news. There's a long list of devices that support the CBRS spectrum for private LTE use today, and 5G capable devices are fast growing as well. So take a look at that URL. I'm sure you will find some familiar names, but I also have some recommendations I will walk you through. So next slide, just a quick maybe recap of what we're seeing in terms of real deployments. I have 2 case studies as well. Indoors logistics warehousing environments, it's the name of the game is ruggedized tablets and smart devices. And you're moving around, the facility changes quite rapidly, where how the warehouse is designed, how much product you have within the warehouse, and how the shelving structure changes. It's a very dynamic environment, 24/7 environment. And for the people who work in the warehouse, downtime is just not acceptable, right? Voice, push to talk, data entry, barcode scanning, just voice communications, they need to work. If you go a little bit outdoors in the next slide, this could be the logistics yard in the same warehouse facility, or something much bigger like a transportation yard, as you see on the picture. Now we're dealing with cranes that are automated, controlled. We're dealing with providing connectivity to in-vehicle, like hostler trucks that might be roaming around the transportation yard, or you might be dealing with video surveillance, because these are critical environments. So we went through probably testing and validation of all these use cases across our customer sites. So 2 of them in the next slides, which you will see, had real business needs, right? Hey, we invested in automated mobile robots. There was about 200 of them in a single facility, and they were trying to automate and accelerate a lot of the supply chain operations in that large warehouse. and they were running on Wi-Fi link where everybody else was, you know, laptops and tablets, and sometimes there's interference, and it's not the best environment for Wi-Fi. So team there decided to move the robots over to CBRS LTE using Sierra wireless gateway devices that I will show you in a bit. So the robots have their own clean spectrum, interference-free, and highly reliable, given the fact that LTE provides us a, you know, somewhat extensive coverage compared to a single Wi-Fi access point. And everything else stays on Wi-Fi. In the next one, similar story, but these are handheld carried devices, tablets, Zebra tablets, and highly, you know, challenging environment, very large ceilings. Shelves can have tons of building material, which some of those building materials, as you know, whether it's wood or metal, could be challenging for wireless signals. Regardless, you know, in this facility, they're taking a CBRS first approach. In addition to keeping their Wi-Fi environment, the number of Wi-Fi access points, let's say, was 50. I'm just making a number up. They were able to just add 20% additional cabling and additional switching ports to add, you know, 10 more CBRS LTE access points to provide coverage to those devices. And they're thinking about extending the ruggedized tablet connectivity to push-to-talk devices and a couple other things. In the next slide, I just wanted to give you guys a picture on what are these devices, what are we buying, how much do they cost, right? How much are we supposed to invest? We've been testing with Motorola Evolve devices that recently hit the market, Android platform, dual SIM, tons of ruggedized features, very good for push-to-talk. And we're able to prioritize and maintain an SLA on latency for these devices based on our lab testing. So highly recommend you take a look at that. Xcover Pro, I'm going to get to it in the next slide actually. And the Zebra L10 tablet that I mentioned, I've been in the market for a year plus. It's hefty price, but it's worth it. All the ruggedized features again. It's 24-hour battery and able to support, you know, a variety of different applications that Windows 10 comes with it. So in the next slide, the Samsung Xcover Pro, I wanted to give it a kind of a special mention because we're observing this convergence of apps, device types, and connectivity in one platform. So Xcover Pro can be programmed to integrate with Microsoft Teams. So there's a side button on it that launches Microsoft Teams and puts you in a push-to-talk team. So you can create a push-to-talk team within Microsoft Teams and integrate with the rest of your enterprise policies on identity management and everything else. So that's kind of nice. In addition to that, it actually allows you to select which application can take which wireless traffic. So you can say CBRS LTE takes this type of traffic and Wi-Fi takes this type of traffic. And you can, of course, manage that using Samsung's Intune, MDM management, and Knox security platform. So you can say 10,000 devices, you're supposed to use these apps on CBRS, and that can be done remotely. So which is kind of nice to see this, you know, a single platform, but multiple wireless technologies and very, very common applications to all of us taking advantage of this new world. And the next one, I kind of talk about the devices that we recommend for those, you know, infrastructure that may not be CBRS capable right off the bat. It could be your automated mobile robots, it could be your video cameras, it could be in-vehicle connectivity. Sierra RV55, fantastic remote management, great performance, ruggedized design, relatively affordable price. Cradlepoint has a very competitive product line, tested well in our labs as well. Ideal for video camera support, to be honest with you. They've done a pretty good job of, I think, testing that, validating that use case. And this router is a CBRS only bridge router, so that brings the cost point down. And compared to RV55, it actually also offers dual band Wi-Fi. So if you have Wi-Fi devices around, it kind of uses CBRS to backhaul them to the network. And BEC even reduces the price point. 2 gigabit Ethernet switch. You can also use USB port to use it as a gateway to jump onto the CBRS band. Again, these are practical recommendations. We deal with these decisions every day. We spend tons of money on these devices every day. So I figured I'd give you a perspective of that. In the next couple of slides, I'm just going to move through them because in the journey, in the landing page that we shared at the beginning, solana.io/journey, you can actually ask for a free trial, ask for a custom demo, see the product in action, see a live demo of the solution, and a variety of other product details. So please come and visit us there. But just to give you a quick preview of what we do, we have essentially taken a cloud networking approach. If Meraki is the cloud networking vendor for Wi-Fi, if Viptela was the cloud networking vendor for SD-WAN, if Palo Alto is the cloud networking vendor for your firewall, we want to be your cloud networking vendor for private LTE and 5G. Give you a single package of solutions, anything from SIM cards to mobile core to network management to API libraries to the SaaS license that gives you access to the CBRS spectrum. Bring it as a package, integrate with your existing network, which I will show you what that looks like, and make the cellular wireless, sophisticated cellular wireless technology to enterprise environments. LTE 5G today is still quite scary to enterprise IT audiences, but it doesn't have to be. You can get started, you can learn along the way. At least you have something that looks and feels like an enterprise networking product. Next slide, just unwrapping the onion a little bit more to show you how do we integrate. So the Solana platform has two components. One, Solana Orchestrator, which is the management plane, and Solana Edge, which is the control and the data plane. And Solana Edge is where the 4G, 5G mobile core lives. And not only lives there, it also, through Solana Edge, it integrates with your existing enterprise policy systems, your layer 2, layer 3 network, your subnets, your DHCP servers, your DNS servers. So imagine you're deploying a Wi-Fi or a firewall solution, you integrate it with your existing layer 2, layer 3 environment. Same idea here. That Solana Edge can live on a private cloud if you want, can live on-prem, can live in public cloud. And then you have the access points at the edge connecting through gateways, routers, or natively capable devices, and tunneling that wireless encrypted traffic to Solana Edge. Inside this network view, there's a virtual view, which I think is coming up in the next slide. Yeah, the virtual view is our secret sauce. Just like any new technology company, we do have a secret sauce. It's called Solana microslicing. It essentially allows you to translate your existing enterprise policy and network configuration to cellular wireless terminology. And in cellular wireless terminology, of course, inspired by 5G network slicing concept, we divide different application groups, different network segments, different device types into these slices. And each slice gets an app SLA. Hey, I want this much throughput, I want this much maximum latency. But it also gives us an ability to route through the network, right? Here's your layer 2, layer 3 network segment. Here's the other one. And then we keep track of the quality of these applications on an ongoing basis on Solana Orchestrator because, hey, that's how we started this journey in the first place. These applications were important to us. We put them on the cellular wireless network. So Solana Orchestrator, as a result, is laser focused on giving you how those app quality metrics are doing, right? So that's kind of the summary of it if you unwrap it a little bit more. So in the next slide, I think I'm getting pretty much close to the end here. Key questions, right? If you have customers in the transportation logistics segment, if you are one in that segment, there's really three teams that we believe impact the future of private cellular deployments. IT teams who are trying to keep the network up, right? They wake up on Monday morning, they don't want to get the news that a portion of the network is down. So uptime. Clearly, it's a clean spectrum. You have SLA-based wireless. You have really good coverage characteristics, industry-wide tested devices that are operating on cellular, a little bit more stable compared to their operational Wi-Fi. So that uptime is supported, that uptime need. Operational technology teams are always trying to push the needle on new apps, new digital initiatives, and they don't have time to worry about if the network is ready or not. They just want to go forward. So this gives them another express lane of connectivity in case they have some new projects. And innovation teams, I mean, who doesn't want to have a private 5G strategy nowadays? So if you don't have one and would you like to talk to us about one, we would love to talk to you about it. But 5G is a topic. It's going to be a transformational technology for many of our industries out there. And you need a private 5G strategy to at least say, here's when I want to start. Here are my key use cases. Here are the business outcomes that I'm looking for. And I think that's a pretty big question for the innovation teams who are thinking about 3-5 years ahead. All right, so Ian, that was it from me. Hopefully that was a good add-on to Nokia and Geoverse content. Thanks for having me.
Great. Thanks, Oza. So I was laughing, I actually wrote something down. Your picture of the home improvement retail store, I think that was aisle 2 at our local Lowe's, because it's about 1.5 miles from my house, and I go on average like 3 times a weekend.
Yeah.
Can't do any job around here. Go to Lowe's.
One day, hopefully they will be a customer, but we wish.
I recognize it. Okay, we've had lots of questions. I'm just going to very quickly go through this. Obviously, we talked about CBRS, we talked about the connectivity issues, talked about those use cases for everything from voice to video to robotic control to ports, etc. And this is complicated stuff. It says manufacturing, there should be logistics. It's, as I think Oza just said, it's kind of scary, but it doesn't have to be. And there's been a lot of companies have deployed network that can obviously be quite interesting and successful. I was actually in Singapore a couple of years ago, and I went to the port of Singapore, which is huge, and they actually were looking at a private network. This is 3 years ago now, to actually control drone trucks to go around and pick up pallets and move, pick up containers and move them. It's all done remote control, and they lose on average about 8 to 10% of the containers every day, which sounds crazy, but if you see the size of the place, and they know it's in the port, they just don't know exactly where it is. And right now they have crews that have to go around and find containers and move them, and that can all be done remotely, obviously with a private network. So I just throw the resource slides up there again. So for questions, we've got several, and actually, Jim, the first one is for you. Mark, yours, one for you. Most logistics leave the facilities to public networks. Are roaming agreements negotiated with folks like AT&T more advantageous, or going directly to AT&T? So, everybody else can jump in on this one as well. So if I need, let's say I've got a port, I've got a private network, but I'm also going to need the wide area. Who do I negotiate that wide area connectivity with? Do I go through you guys, or do I go talk to AT&T, Verizon, Vodafone, etc. myself? So Jim, you want to start?
Well, roaming's roaming you can get dragged into a roaming conversation that will never end. But here's a skinny on roaming agreements. There is a kind of a select group of operators around the world that are part of this GSMA club, where you actually have reciprocal roaming agreements. And it's not that, they're not looking for new members new roaming members. So where roaming was really, really popular years ago to fill holes, to do a lot of things, it's not so popular anymore. So chances of anyone getting a roaming agreement with an operator is probably less than 1%. So by having this pre-established reciprocal roaming agreement in place, because of other demands and requirements of the carriers, is going to be required. So you're going to have to go to somebody who's willing to share that resource with you, whether it be us or somebody else. The odds of a port or anybody negotiating a roaming agreement with an AT&T or Verizon is going to be really, really hard to do. And if you go down below that to a warehouse or industrial facility, it's going to be really, really hard to do. They're pretty much not interested in that.
Right. Okay. So Mark, question for you. It's kind of related actually, but I think they're talking about here about the Port of Seattle there, that example you gave. Do you integrate applications like LiDAR, radar on the cameras for controlling that port traffic? Was that all pulled in there at the same time as well?
So I think what we provided for the Port of Seattle was a basic connectivity model that would form the foundation for them being able to add other technology requirements as they grew into them. So certainly our solution is flexible enough to incorporate all those use cases. And as for the earlier question about roaming, with our solution, you can purchase it through the carriers as well. So you can have the best of both worlds, or you can have private LTE on-prem with integrated roaming agreements with the various different carriers. So there was all kinds of flexibility there.
Okay. So Oza, you've mentioned Wi-Fi. We obviously talked about CBRS. So there's a question here actually about the use of multiple bands. And I'm actually going to expand the question a little bit. So do you find that one band suffices like CBRS, or you have to bring another band in as well? Are you mixing Wi-Fi in there at the same time? Or is it dependent on the application?
Yeah, it might be a bit dependent, but enterprises, the networking teams that are already in place have put in quite a bit of effort to get their Wi-Fi system manageable in a large scale with device management, security, and a variety of other things. So they already operate in 2.4 and 5, and they sometimes segment devices on those two spectrum options. CBRS is a welcome option for them, and honestly, if we can make other spectrum options as easily accessible and cost effective as CBRS, they will take it. They will take the next spectrum right away. You know, the moment we presented them, hey, you get to access this new spectrum by just buying an AP and deploying it, they're like, okay, let's give it a try. So they're ready to go because they like cutting cables, they like reducing costs, they like more wireless and mobility, as long as they can be centrally managed. So the short answer is, you know, give more spectrum to enterprises, whether it's something else, whether it's an expansion of CBRS, they will take it.
Yeah. So Mark, and Jim, I'm going to come to you with a different question in a second. Mark, in Seattle, there you had band 48 and band 53. Was there a specific reason for that?
Additional resilience in the solution.
Okay.
So in the port environment, you know, as any communication systems, the more spectrum that you can throw at the solution, the better off you are. So that was the choice, to just get additional spectrum besides the CBRS band.
Right. So Jim, one for you here. You actually mentioned at the top of the presentation about the spectrum bands and millimeter wave, and I'm looking for the question here. So something like millimeter wave obviously doesn't go as far as the mid-band or the low-band spectrum. In private networks, is it sufficient to cover something like an airport or a port, or is it more for indoor, you know, shorter range? What are you finding with that?
Well, first of all, with millimeter wave, it generally is not available for the enterprise to use. The carriers bought all that spectrum, so it generally is not available for them to use. But the carriers are kind of, like I said, using it for fixed wireless, so last mile for a broadband pipe, or in really dense urban environment where you got so much traffic that you use this, and a lot of them are using this as their 5G platform, and that is, like I said, typically in dense areas. The minute it hits a glass, the minute it hits tree, the signal stops. So that's what you're dealing with. But it is a giant pipe, so that pipe allows for, you know, a lot of traffic and you know, good things, but it just is very, very short distance.
Right. Okay, well, we're just about out of time. Oza, Mark, Jim, thanks very much for the time. For those online, we've of course been recording today. The recording will be available today, tomorrow sometime. We also had quite a few questions asking for the slides. I'll send details on how to get the content as well as the presentation itself. And there's a couple of follow-up questions as well we didn't get to, but I'll send those to you guys, and you can contact the folks directly. So guys, thanks very much.
Thank you.
Thank you.
Thanks, everyone. Thanks, Ian.
Thank you.